All right, guys, here's a few review questions. Take a few minutes, pause the video, and try these before you watch the solutions. Now that you've tried these, hopefully you were able to solve these equations. I'm sorry if you didn't know that's what you were supposed to be doing. You may want to go ahead and try them again now. But we're solving the equations here. So on the first one, to get x, I'm going to add 1 to this side. To get rid of the minus 1, it cancels out. 7 plus 1 is 8. Then I'm going to divide by 2 on both sides. X is equal to 4. Again, I'll remind you something that we've talked about all year long when we've been solving. What you do to one side, you got to do to the other. On number 2, you have a minus 7. So we're going to add 7. Add 7 to 5. 5 plus 7 is 12. Then we are going to divide by 3. Divide by 3. That gives me 12 divided by 3 is 4. On the next one, little trickier here. It is a positive 3.3, not subtracting 3.3. So you need to subtract because it is a positive 3.3. The negative in front of this 4x still stays there. That is a minus 4x or negative 4x. Then you do 2.5 minus 3.3. It is my strong encouragement that whenever you come across decimals especially, don't try to do too much in your head. Even I mess up a lot of times when I'm trying to subtract and add decimals in my head too quickly with money even. So very important to take that 2.5 minus 3.3 and actually type it out in your calculator to see that it's negative 0.8. So just be careful. That's all I'm asking. Then we divide by negative 4. We divide by negative 4. If I divide this negative 0.8 by negative 4, it will tell me 0.2. So my answer for x is 0.2. The last one, number 4 here, of solving these equations. First of all, on this one, we're going to subtract the 5. Subtract the 5. These cancel out. Gives me 2/3 x equals negative 6, because negative 1 minus 5. Then we want to get rid of the 2/3. There's two ways to do this. You can divide by the 2/3 like we've divided here, divided here, divided here. Or you can also multiply by the reciprocal. My personal opinion is multiplying by the reciprocal just because multiplying by the reciprocal is easier to type in the calculator, in my opinion. It also cancels out the 2/3 when you multiply by 3/2, or 3 over 2 times 2 over 3. The 2's cancel, the 3's cancel. It's just x. Like I said, I think it's easier to type in the calculator as 3/2 times negative 6 versus trying to divide by 2/3. But if you take negative 6 and you divide it by 2/3, you're still going to get negative 9 either way, because that is the answer. Finally, a little bit of review from what we did in last lesson. We have solved this inequality. Remember, solving an inequality is basically the exact same way that you solve an equation. The only difference is when you multiply or divide by a negative, you flip the symbol around. So if we divide by negative 2 on this one, you get x is greater than, and then divide 14 divided by negative 2 is negative 7. We also talked about the graph of those and what those look like. You would have a negative 7 here, negative 8 here, negative 6 here. Remember, the negative numbers, they look like they get bigger this way, but they're really getting smaller. Be careful there, because that means you're going to have an open dot here, because it doesn't have an equal to. X cannot be equal to negative 7. X is greater than negative 7. And so those numbers that are greater than negative 7 are actually this way. I mean, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6, 7, 8. Keeps on going. But remember how a number line works when you're thinking about the graphing in one variable. Later on, next week, we'll talk about how to graph in 2 variables. So, today's lesson is going to be relatively short because the main push of this lesson is solving inequalities like we did last time. The only difference is we're going to add in multiple steps like we did in questions 1 through 4 on these warm-up equations. we're going to be looking at multi-step linear inequalities. So it just means you're going to be doing more than one step, just like we did with the equations. But you don't change any solving techniques like we haven't done before. So take a chance here. See if you can solve this guy. Don't worry about graphing it, just solve it. After you've solved this, hopefully you realize that I got a minus 5 here, so I need to add 5. Add 5. That gives me 2y is less than 12. Notice the only difference there, instead of an equal sign, I've got a less than symbol. Then I want to get rid of the 2, so I divide by 2. Divide by 2. Y is less than 6. Notice I divided by a positive 2, so I don't flip the symbol around unless I multiply or divide by a negative. So this is y is less than 6. So that means basically, and we're not going to, you don't have to draw the number line here, but that means any value less than 6 this way, if I plug in any number that's less than 6 into this equation or inequality, it will be true. If I plug in 5, if I plug in 4, if I plug in 3, if I plug in 2, if I plug in 1, it's all going to work. That's what we mean when we solve something. We are finding solutions that work. That's the whole point of the word solution. All right, here's another one for you to try. Another 2, for you to try. Pause it and try them. After you've tried these, here's the solutions. We subtract 4 on this one, subtract 4 on this one because it is a plus 4. 2 minus 4, be careful there. Remember, subtract 2 minus 4. Then we have a negative in front of the x. That's really like negative 1x. So we divide by negative 1. We do have to flip the symbol around, and that would be positive 2. Negative 2 divided by negative 1 is 2. On the other one over here, we have x over 2 minus 2 is less than 5. So we add 2 here, add 2 here. We get x over 2 is less than 7. 5 plus 2 is 7. Then we want to get rid of division. So the opposite of division is to multiply. So we multiply by 2 on this side. We multiply by 2 on this side. 2 times 7 is 14. Again, these two solutions here for these two different inequalities are telling me that if you plug in anything less than 14 right here, it should work. If you plug anything less than 2 or equal to 2, it should work. That's the whole point of solving. All right, here's a couple more for you to try. A couple more multi-step. Pause it and try them. Now on this one, here's my son. Hold on. Sorry about that. My son got his little basketball stuck on top of his dresser. He plays basketball in the house on his goal. So, solving these, hopefully he paused it and solved them. So we subtract 5 on this guy, subtract 5 on this guy. And that gives me negative x is greater than 4 minus 5 is negative 1. This one's a little weird here because you do have a negative 1 in front of this x. You have to divide by negative 1, divide by negative 1. That means you need to flip your symbol around because you divided by a negative. Be careful here. This doesn't cancel out in the sense it's not 0. Negative 1 divided by negative 1 is positive 1. The reason we say it cancels out over here on the left is because negative 1 divided by negative 1 on the bottom is really 1x. That's why we say it cancels, but it's not 0. Be careful. Adding and subtracting two numbers together, plus 5 and a negative 5, that cancels to 0. On the other one, a little tricky here because you have a variable on both sides. So this goes back to something that you need to remember from equations. We talked about taking the smaller one, in this case 2x is smaller than 4x, and doing the opposite of 2x would be subtracting 2x. What you do to one side, you have to do to the other. So subtracting 2x here, subtracting 2x here. This one cancels out because that is adding and subtracting like we just talked about. That's 0. Over here, 4x minus 2x is a positive 2x. Then we get rid of the minus 1 by adding 1 adding 1. Once we add 1 to both sides, we have negative 4 plus 1 is negative 3. Sorry about that negative 3 there. And then that leaves me with 2x over here. We divide by 2. Notice we're dividing by positive 2, so do not flip the symbol, only when you divide by a negative. And negative 3 divided by 2 is negative 3 halves. Or if you do negative 1.5 as a decimal, that's okay. So that's what you do when you have a variable on both sides. I will warn you ahead of time. Occasionally you will run into a problem where you may have, let's say something like 6x minus 4 is less than or equal to 3 times 2x minus 7. And you have to distribute this 3 to both sides. That gives me 6x minus 21. Then over here you have 6x minus 4. Well, if you take both sides here and you subtract 6x here, and you subtract 6x here like you're supposed to move it from one side to the other, it cancels out, and it cancels out. That means there's nothing left with x's. You have negative 4 is less than or equal to negative 21. So you don't have x equals, or x is less than, or x is greater than. You don't have any of that. It just gives you two numbers. If that happens, we've actually seen this before with equations a long time ago. But when we have this, we look at the statement that is there and decide if it's true or not. Is negative 4 less than or equal to negative 21? No, it's definitely not equal. And it's definitely not less than negative 21. So that means that this statement is not true. And because the variables canceled out, that means there is never going to be anything that makes x be true on both sides. So that means there's no solution to this inequality, excuse me. All right, so we're going to finish out this video with a couple of problems that are word problems. Everybody's favorite, right? Let me shrink that down just a little bit more. All right, so I'm going to go through these with you. You're welcome to pause the video and try it as well before if you would like. It says in 1990, Nashville, Tennessee had a population of 985,000. From 1990 through 1996, the population increased at an average rate of about 22,000 per year. Write a linear, linear. Oh, MX plus B stuff. Write a linear model for the population of Nashville. So this is a rate of 22,000 per year. This is the population in 1990, which was the beginning year. So there's my M and there's my B. So for Tennessee, the population is equal to 22,000 times x plus 985,000, which means basically every year they're gaining 22,000 people, but they started at 985. That should be logical even if you don't go through and write it maybe in quite this order. 22,000 times the number of years plus the original amount. That's mx plus b. Now you could also put y here instead of p if you wanted to. For Las Vegas, the population was 853,000 in 1990, and their population increased at an average rate of 58,000 per year. So their population in Las Vegas is 58,000 per year, so 58,000x plus 853,000. Notice that their beginning amount is lower, but their rate of change is increasing quicker. So it says, when will Las Vegas's population be more than Nashville's? So they're increasing quicker, but they started off lower. So now the question says, when will this population be more than this one? And that's what an inequality is. 58,000 x plus 853,000. When will that be more than or greater than Nashville, which is 22,000 x plus 985,000? And if you solve this for x, it will tell me the number of years it takes for Las Vegas to be more than Nashville. So, to save a little bit of time, I'm not going to write down every single little step here, but I'm going to subtract 22,000 from 58,000. If I subtract 22,000x here, let me go ahead. I'm going to go ahead and write down. I've changed my mind. Subtract 22,000. I take 58,000 minus 22,000, and I'm going to get 36,000. So that's 36,000. Then I have 853,000. I want to subtract 853,000 from 985,000. So I am going to skip the step of writing that one down, just because it's a lot of zeros and stuff. But 985, golly, sorry guys, minus 853. So 132,000. Then we divide, just like we normally would. We divide by 36,000. So we get x is greater than. So we take 132,000 divided by 36,000. Press enter, and we get 3.66666666 repeated. And that's an approximation there. But what does that mean? Well, that means after 3.5, a little over 3.5, because it's 3.6 years, Las Vegas's population will be more than Nashville's. That doesn't give me the exact amounts, because we don't know when exactly the census would be taken. We don't know exactly which months are bigger than others. We typically, well, there's a lot of August birthdays typically, but we know that the population is increasing there. We also don't know, people move in at different times of year and move out at different times of year. All right, the last problem for today. The last problem, let me make sure I'm not lying to you. Yeah, last problem for today. Says you see an advertisement for instructions on how to tie flies for fishing. Some of you have been fly fishing before, possibly. The instruction book costs $13.95 plus $1.05 in shipping. The cost of materials for each fly is 15 cents. You plan to sell each fly for 58 cents, and you want to make a profit of at least $200. How many flies will you need to tie and sell? So you want to make a profit of at least $200. Now let's go back and let's think about this. We've talked about this a few times this year. Profit is the money that you make, or in business terms, the revenue minus the expenses, how much you spend. So the money you make minus how much you spend. We want this to be at least, so that means greater than or equal to, I'm okay if it's equal to $200 profit. Well, what are my expenses? What are the things that I had to pay for? Well, I had to pay for the instruction book, $13.95. I had to pay the $105 in shipping. So if I'm talking about that, that means I've got $13.95 plus the $105 in shipping. Press enter. That's $15 of expenses. But here's where you need to be careful. It's not just $15 in expenses. I also have the materials for each fly. So each little fly that I make for fishing is 15 cents. So I also have to subtract out 15 cents per fly. So times, let's use X. Or if you want to use F for fly, that's fine as well. In fact, I'm going to do that. Let's change the variable up a little bit here. Show you that doesn't change what you do to solve an equation. You plan to sell each fly for 58 cents. So this is where the revenue comes into play. 58 cents times F is how much money I make. Notice that's the only thing that's positive here, is that 58 cents. So what this now will do is this will give me the ability to solve and find out how many flies I need to make in order to make $200 at least. So if you subtract 0.58F minus 0.15, again, use your calculator to help you with decimals, 0.58 minus 0.15, you get 0.43. Now think about what that means. That means 43 cents per fly is how much profit I make off of just the flies. But I also have the minus 15 right here, the $15 for the instruction book and shipping. So if I add that to the other side, I add that to the other side. If I'm making 43 cents for each fly, I need that to be greater than or equal to $215. 200 is what I want to make, but 15 I already spent on the instruction book and the shipping. So if now you take this and you divide by 0.43, divide by 0.43, it is going to tell me how many flies I need to make. So I take 215 and I divide it by 0.43. It tells me that I need to make 500 flies. Now that's ridiculous. That's a lot of flies for $200 only. If I make more than 500 flies, I'll make more than $200. But let's put that into perspective. A lot of people think that they can start these nice little side businesses of making these necklaces or goofy little things like that and selling them at the jockey lot or something. 500 flies just for $200. Think about that. If each fly, okay, let's do some real life math here. 500 flies, and that only gets me $200 in my pocket. If each fly takes me, on average, 10 minutes, that is 5,000 minutes if you multiply 10 minutes times the number of flies. 5,000 minutes, if you take 5,000 minutes and you divide that by 60, that will tell you how many hours you have. That's 83 hours, 0.33. Now, I'm just going to leave it as 83.33 and not really worry about it. It's 83 hours, whatever. If you take $200 that you made and divide that by, let's just round it to 83 hours, you're only making $2.41 per hour. Now, I don't know about you, but that's not a good rate. Now, if you enjoy tying flies for fishing, it's not a big deal, and you're like, it's just something I do on my leisure time, then whatever, that's fine, and maybe you're making some money that you wouldn't make before. But if you're expecting this to be a profitable job, you just screwed up, because $2.41 an hour is not going to get me a lot. So when I think about that, what I want to think about is not just, oh, look, I can make some extra money, Mr. Harrison. I really need to make sure I think things through completely when I'm deciding to do something like this. I could go get a job at McDonald's and make more than $2.41 an hour. So be careful. And there's going to be a lot of things out there in life that lure you in like that. Ladies, I'll call you out. There's a lot of ladies on Facebook that will do these different little makeup things and think they're making all kinds of extra money. But if you're not selling thousands of dollars worth of material, you're not really making a lot of money. So you need to be careful. You need to make sure you actually count the cost of what you are having to pay for materials and things like that. Count the cost of how many hours you're actually spending. Don't just look at the money that's coming in. You also have to look at the money that's going out and the time that's going out. All right, guys. Hope you enjoyed that. That's a little life lesson there for you. So, your homework will be posted later. Good luck, guys.